No, so with the gas gun, it relies on pneumatics for a shock, for a floating brake on the bottom.
Mm-hmm.
So the first thing we need to do is come all the way over here and turn on the air pressure. So it's behind here. So it's on already,
Okay.
but you'll just turn that. That will be off, and you turn it on. It will hiss for probably 15 or 20 seconds as it fills up, and then it catches and stops.
Is it normally turned off?
Yeah, so it'll normally be off.
Okay.
And so that's the first thing you do.
Okay.
Number two, when we're done with these, we unhook the bungee cord so that they're not stretched, and they just come off of the pulley.
The pulley.
So to apply it,
Yeah.
so it'll be loose. You get both of them on the two pulleys down below. I took them off, so now I gotta do it again. It's a little awkward, but not too bad.
Okay, I see they're on separate pulleys.
Yeah, so there's two pulleys, and then it comes up and just goes around. There's a pulley right there.
Okay.
So you do it on both sides to have that. And then we want to mount an accelerometer onto the plate itself.
Okay.
So that will tell us what the input acceleration is.
So I assume that's the first one.
Yeah, and this one right now is a triax, so it comes into our test partner, the data acquisition system.
Oh.
And then we have another one that would go on top of the
Test subject.
Yeah. So that's what you need there. And then to turn it on, you come over to this box and you turn it on. Really hard.
Is the key always there?
The key's always there.
Okay.
So that's kind of like a nuclear.
Oh, and you have to turn it to start. I forgot
Okay.
that.
Roll it a few times.
And then it takes a minute or two to pop up.
Okay.
And so the drop tower is completely separate from the data acquisition.
Okay.
And so you can run the drop tower without taking data. You can take data without running the shock tower, but you don't want to do that. I mean, some people do.
Yeah.
How can I see it's just booting up?
Yeah, so it's just booting up. So it's fairly simple. You can lift the hoist up, you can drop it down. What we can do is on the top here, the table position, we have a drop height, the DH, so that we can go and set how high do we want it to drop.
Right.
And then, so right now we're at 13. I can then push the hoist up, and it will lift it to 13 inches, and then stop.
Okay.
Oh,
That's what you programmed it to do.
Yeah, so it's programmed in so you can get to the same height every time. And we can change what it is. You can zero out, where zero is, but whatever. And then to fire it, you just hit arm and push to drop. And then it will drop.
That's sick.
And then it will automatically go down and reconnect to it. And now it's ready for another shock.
And did it already move it up to the same height that it was at before?
No, so it's just lifted it up 2.45 inches. So on here it tells you where it's
I
at.
see in that top left corner.
Yep. And so then I can lift it up higher, whatever.
Okay.
And there is an auto drop. I haven't used that, but I think it's just you push it and then it will just it'll ask how many cycles and it will just do it. Okay, for the data acquisition, the first thing you need to do is turn on the test partner,
Okay.
and you wait until the status light is on. And then in here, you go to tp4.exe, test partner 4. And so it will open up, and you can go into setup and then recording setup, and that's where you choose what channels you have. You put in the sensitivity of the accelerometers, and so I've already put that in. You put which trigger you have and what the trigger level is. 10 Gs seems to work okay. It will trigger as it like moves up because as it's shaking. So normally before you take the data, you lift it to where you want it to be, and then you start the data, and then you drop it.
Okay.
Okay.
These are all ICP accelerometers, so you'll need to make sure those are checked. I would guess as you're testing this will just stay the same.
Right. once
If we have the
set.
same accelerometers, we'll just run it
Right.
like that.
Okay.
You can here change the record time, how long you record the sample. With the shocks are very, very fast. So we're running for 0.2 seconds is all. With something like the tensegrity, we might want to extend that out
Okay.
and maybe not sample at 125 kilohertz, but maybe drop that down.
Right.
But we can play with that. So then you hit OK,
Okay.
and then you go into record and you do acquire data. And now it's ready to go. Well, here, let me cancel this. I'll lift this up. And now I can hit acquire data. It's ready to go. It's off of the Z axis. And so I drop it. Oh, it triggered before it dropped.
Oh.
So we'll have to,
Oh.
So the trigger is basically a threshold. Like if it experiences that much,
Yeah.
it'll start recording for that
And
0.2
so-
seconds.
I mean, if we change that to, let's try 100. Jeez.
100 times gravity.
So now it's like 10G. Is
I think before it was 10G. Now it's 100, right?
Yeah.
Okay.
And so then now we have that shock. And if you notice, this is 20 milliseconds or 0.2 seconds,
second.
and
Just
we got to over 1,500 Gs
dang.
on that shock, and we have our data. And so and then I won't go through all of it. You can save it, and it can post-process some here, or we can just get it into MATLAB and
Okay.
do what we want with it.
Is it hard to move data off this? I assume we would plug in if we want to move data off the
Yeah,
computer.
and if we want, we can connect to the internet right now. We have a laser vibrometer that uses the Ethernet port,
Okay.
so you have to
Oh,
unplug
so you
that.
switch that out. over
But
there.
then you can just go and save it to a box folder or whatever you want.
Okay,
Okay.
that's awesome.
Just one question. What's
Uh-huh.
the G again? Is that like
That's
gravitational-
gravity.
Oh, it's a gravity.
9.1
9.1 meters
so-
per second squared.
1,500, so we're at,
It's like
you know,
What is
1,500
that?
times
1,500 meters per second?
Yeah,
1,500
whatever.
times. No, that's
Yeah.
way bigger than that. Yeah, I was gonna say I can't do math like that in my head.
it's a lot.
it's high.
Oh, that's great.
And so you can play with all of the variables of how you want to do it.
Okay. That's awesome.
And, you know, how many data points you take, how long it is, all of that.
Okay.
Mm-hmm.
Awesome. Okay. So it seems like we won't be able to test this until we have something that set the other one on top.
Yeah.
Um,
So we could just put like a plate on top of it. The accelerometers cost $1,000 or so. So
Yeah.
I'd rather the plate not bounce off and we break the accelerometer.
yeah, I would also rather
Yeah.
not be responsible for that. Does that mean when we print the plate, we'll need something to fix the accelerometer in place onto the
So
plate?
the accelerometer, you just use a little bit of wax.
Okay.
okay.
And so, like
Is that like place a rolling like glue?
yeah, so you'll just go and,
That's $1,000.
yeah.
The glue?
Wow.
Because it
wax.
can survive 100,000
Oh, this
Gs.
one.
Oh my gosh.
And so you just go and get a little bit of wax
Mm-hmm.
and you stick it on,
Uh-huh.
and then you push that down onto the plate, and it
Sticks on there pretty well.
stays on there, yeah.
Okay.
'Cause there's very little mass to that accelerometer.
There is very little
So it
mass.
doesn't try and pop off very easily.
Okay, and so one is set to the bottom, and then we would set one on top of it.
Yeah.
And that records the difference between this. Is there a place?
Yeah, so channel 1 is this
Okay.
white cable here. That's the one that I would put this other accelerometer
Okay.
on
Yeah.
and put it on. And this will record X, Y, and Z. Right now I'm just using the Z axis.
That makes sense.
Couldn't find my other accelerometer, so we're using the triax.
Okay.
So when you say the top and bottom, does that mean it's like above the plate and then below the?
So this will be, I have one on the surface there, which
Yeah.
is the bottom. That will be the input going into the
Yeah.
the piece, and then we put a plate on the top. We put the second accelerometer.
Okay.
So the acceleration should be different, and it's different by how this moves.
Smooth. Yeah.
The other thing we could do is if we put a plate on it, and then we have a high-speed camera and measure how it
Displaces.
displaces. That could also work as well.
And you have a high-speed camera. And...
No, we just borrow it from the PSC when we use
Ah,
it.
cool.
Okay.
But like iPhones are pretty good. Probably with this, the high speed portion would probably be good enough.
I imagine.
At least for some preliminary
Yeah.
Okay.
views. on
Print a
it.
tripod for it.
I mean, iPhone.
Yeah. Just to hold it in place.
So it's not pro. I don't know.
Okay.
So that's the drop tower.
Okay.
We also have, if instead we wanted to like drop a weight on top of it, we have this small drop tower here, which we can just lift this up to a certain height and then drop it
Yeah.
onto a plate that's on top of it and see how it works.
Okay. And then we just set a camera
Okay,
up for
exactly.
that.
Yeah, you can
Oh
have
yeah,
a camera
definitely the camera.
up for that. We could, well, having an accelerometer is hard because I guess you could put it on the bottom of the plate.
Yeah.
You just don't want to damage it.
Yeah, you're gonna have a lot. So, one challenge with this, and well, with both of them, is this gives us the shock. It's not necessarily how this moves.
Yeah.
It's the initial displacement that happens very, very, very quickly. After this, then you have everything moving, and so that's also something that we might care about. For actual shock, like, if I'm protecting electronics especially,
Yeah.
it's this initial shock that matters, not everything that happens afterwards.
Makes sense.
If we are like trying to protect a body being run into by a car, then all of that other stuff also matters.
Yes.
It's not nearly as high as this, but it lasts a lot longer, so there's a lot more energy in it. This program is specifically for very fast things. We can take more data,
Impulse.
but we're going to have to decide,
Yeah.
and maybe we just measure the first 2.2 seconds, and we measure 10 seconds on a second shot, and look at all of it.
That makes sense.
Yeah.
Okay.
If we want, we haven't talked about this, but I also have a shaker, and so we could go and mount this on top and change the frequency, so we could see as I'm shaking the bottom, what does the top do?
Right.
And so it's possible that at very high frequencies that we get more attenuation than something else. So if we ever want to go this way, it's fairly easy to set up and just measure basically the transfer function. Given a frequency, what does the output look like?
Okay. Yeah, we do need to spend time and just decide what tests
yeah.
we want to do, and then I think on Friday we'll let you guys know what we're thinking, and we can discuss it together and
Yeah.
make it solid or get feedback on that.
Okay.
I imagine we won't be shooting big metal sables at it, but
But it would be really
it
fun.
would be really fun.
I was excited about this.
I was gonna say
I do think something like this, if we went and shrunk this down and now we make multi-cells and we have
Yeah.
more like a foam-like structure, that's something that we might think about doing here, where we
that's true.
Yeah.
maybe not shoot a slug right into it, but put it on the resonant plate and see see what it does.
Mhm.
Because this will be a longer shock impulse than the drop tower. The drop tower is very high, but very, very short.
Short, yeah.
And this will have a longer impulse.
Okay.
Yeah, that makes sense.
Yeah, that makes a lot of sense. It's cool. All right.
So,
You have any questions?
I'm good.
I don't have any yet.
And I know on the computer there is an explanation of how to run everything. I just,
Don't
in the
know.
5 minutes I looked, I didn't find
Okay.
it.
Okay.
So
Does it have a
it's-
password or anything?
It does. Are you
You-
still
I can turn it off for that. Let me
And-
just start filming again.
So turning off everything.
There's a button that says shut down system. You push that and say yes. It is pretty idiot proof.
I hope.
Oh, so
I'm an idiot.
Yeah, it will lower it down. It will eventually power off. You may now power off the system, so you turn it off.
And then we turn the air
And
off.
we turn the air off and we unhook the bungee cords.
okay.
Okay. On that side and this
Yeah,
side?
both sides.
Okay, so both sides each time. We'll do that.
Yeah, just because it sits here for so long, we don't want them stretched out.
Right.
Okay.
And this one here comes off from there. And do you just sit them on the side?
Yeah, I
Okay.
just leave them like
Perfect.
And then the only thing really to make sure of is the cables for the accelerometers. Before we drop stuff, just make sure that they're hanging nicely. I just put it over the power supply. Maybe we should have a hook or something. But
print one.
we don't want that to get underneath because then
No.
we'll break it and
Yeah.
it's really hard to splice the wire. So
I can imagine. Yeah, we've had some experience trying to do some kind of stuff like that with BattleBot, but it's not near as complicated wire.
Oh, yeah.
Yeah.
That's quite fun.
Okay. I think that's everything for that.
okay.
We'll get to printing more models and then